Hi class, it's me back again, and I spent like way too long trying to get the lighting right, and that's why I'm sitting on the stairs in my house, and I'm here to talk to you about chapter 9. I was going to try this little video to go over some of the objectives of chapter 9, so let's take a look at chapter 9. About to share my screen. Where the heck is it? There it is. Okay, so I'm on my lecture for chapter 9. That, of course, is available to you through the Canvas webpage. All right, come on now. Okay, so obviously that's me. We're going to be talking about experimental research, one-way design. So here we go. Our objectives, I'm just going to go over one objective at a time. So we're going to go ahead and start with the first objective, which is to explain the basic concepts of experimental design and be able to design your own experiment. So what is an experiment? Well, experiment is a little bit different from a study. It's a type of study, and it's a type of study that's designed to show how changes in one variable cause changes in another. So it's a type that shows cause and effect. So some kinds of designs, like correlational designs, will only show whether things are related to one another, but the experimental design shows cause and effect. So the way we structure an experimental design is using an independent variable and a dependent variable, sometimes referred to as the IV and the DV. So the independent variable is the cause, and what we do with an independent variable is we manipulate it. And when we talk about one-way experiments, which we're talking about in this chapter, that means we have one manipulated variable or one independent variable. And I'll talk about the manipulation of that in a minute. And then the dependent variable is the effect. And the dependent variable is what is measured. So for example, if we have a drug that is intended to treat the coronavirus, then we might test that drug with a treatment, would be the drug, and it would presumably cause changes in behavior, and in this case, illness. So if we give the drug, we expect it to cause changes in behavior. So the drug would be the independent variable, and it would, because it's causing changes in rates of illness, the rates of illness or the change in behavior would be the dependent variable. So the treatment is the independent, and then the outcome is the dependent variable. Okay, so let's take a look at some of these, and you can pause the video at this point and see whether you can answer these questions. Are the following hypotheses causal or correlational? So if we say elderly people with pets are buffered from the impact of stressful life events, what you might ask yourself is, what's causing what here? Is there anything causing anything else? Well, as I read it, we could restructure that to say that pets protect people from the impact of stress. In this case, pets would be causal. Pets are actively taking down stress. Okay, so that would be causal, and that would be we would use an experiment to test that, as opposed to a correlational study. Among people with AIDS, pet owners have a lower incidence of depression than people without pets. So you might ask yourself, in this case, is it causal? So we've got people with AIDS or HIV, and it seems that people who own pets have a less incidence of depression than people without pets. So we got two groups here. We got a group that has pets and a group without pets. And people with pets are doing a little bit better. Does that necessarily mean that pets caused that? And I think that the way this is written, it does not mean that. It may be that people who have pets are just richer, and so in that case, they can afford better treatment or something like that. Same thing with number 3 there. Just talking to pets compared with talking to people is associated with lower cardiovascular responses. Notice that that word is associated does not necessarily mean causes. So it could be that for whatever reason, talking to pets it goes along with lower cardiovascular problems, but doesn't necessarily mean it causes it. The presence of pets reduces blood pressure of children reading aloud. There we see that causal word again, reduces. It actively changes. And pets ownership is associated. Here again, we see the associated. That is correlational. Okay, so steps to designing an experiment. If we want to design an experiment, the first thing we got to do is develop a hypothesis. So let's take an example hypothesis. Movie watching together strengthens marriage. Now notice that that strengthens is a causal word, right? Because it's saying that movie watching actively improves marriage. So what is the independent variable and what is the dependent variable? Ask yourself. So movie watching, what causes what is what it's saying, and the independent variable is the cause and the dependent variable is the outcome. So movie watching there is the cause or the independent variable, and the marriage or the quality of the marriage is the dependent variable. So now we got to operationally define these variables. Really, what does it mean to watch movies? How much movie do you have to watch? How many movies? Over what time span and stuff like that? And what does marriage quality really mean? And so how are we going to measure that? And once we get that all straightened out, now we get a group of people, we get a sample, and just the ways we've always been talking about getting samples. Say we do a convenience sample, we just go grab a bunch of people. And then what we do is we randomly assign each person to groups. And that is the same use of the word random that we've used before, but we've got two groups here. We've got a group that does not watch movies and a group that does watch movies. And we're going to make sure everyone's randomly assigned, meaning that everyone has an equal chance of being in either group. So for the first couple, we flip a coin. Heads, you watch movies together, tails, you don't. And then, we form our two groups that way. So now we have a group of people that got heads, a group of couples that got heads, and they're going to watch the movies together. And then a group of couples that got tails, and they're not going to watch the movies together. So that's going to help us make our groups as equivalent as we can in every single way possible. So it's very unlikely that we're going to get, let's say all black couples in watching movies and all white couples not watching movies, for example, or all the older couples watching movies and all the younger couples not watching movies. Because of the way we assigned them, we basically make each group totally equal. And then we're going to manipulate the independent variable. One of the groups is going to watch the movies and one of the groups is not going to watch the movies. And then in the end, we're going to measure how each of the groups are doing in terms of their marriage. Okay. So why do we randomly assign? We randomly assign to keep groups equal on everything, on gender, on age, and ethnicity, and religion, and everything else that we don't even know about with these people. If we flip a coin, we end up getting two groups that are roughly equivalent in all of these things, because ultimately the idea is the only thing we want them to be different on is the independent variable, which in this case is watching movies. That's the only thing we want different with these groups. We don't want some groups to be one group to be super healthy and the other group not to be super healthy or whatever. It has to be exactly the same in everything except watching movies. And that's how we get cause and effect, because if it's the same in everyone and everything besides watching movies, if both groups are exactly the same, but one group watches movies and one group doesn't, and then we find out that the group that watches movies have better marriage, then we can be sure, for sure, since nothing else was different between them, that the group that watched the movies was better in their marriage because they watched the movie. So that's the way we get cause and effect. The independent variable causes the dependent variable. And we have to do that for random assignment. Okay, so you try this. This is no random assignment. I want you to tell me what's wrong with it. So in an experiment testing the value of summer school on children, we get children from school X. Now, school X is the poor school. It's in a rough area of town where the property values are very low, and so the school doesn't get much money. There's a lot of drug problems. People don't make much in that part of town. The school's not that great. And then children from school Y, which is the rich school, and everything's really good in that school, and everything's wonderful. And then it turns out that we give oh, I think I screwed it up. School X is the rich school, actually, and school Y is the poor school. So those who get the program turned out to be more successful. Then the question is, well, wait a minute. Isn't it a possibility that because school X was this really rich school, they might have performed better anyway, even without this treatment? And so the question is, how would random assignment solve this problem? Well, what we would do in random assignments, we'd take all these kids in a big group and we'd flip a coin with every single kid. Heads, you're in the summer program. Tails, you're not. Heads, you're in the summer program. Tails, you're not. And you just do that with every single kid. Now you got two groups. Some of them go to rich schools. Some of them go to poor schools. Doesn't matter. They're equivalent groups. We've got males and females in each group. Woo, coronavirus. And we've got basically equivalent groups. Okay, so random assignment solves that problem of the rich school and the poor school making a difference here. Whoa, one too many slides. Go back. Okay, so when we manipulate the independent variable, it's going to have at least two levels. And when you talk about one level, it's called a condition. And so, you know, we have this reading group condition or the summer program condition, and then we can often call that the control condition is the other condition, the group that doesn't get it. And so we have an experimental condition and a control condition in this experiment. It's the same is true of the marriage experiment. We got people who actually watched movies together and people who did not. People who watched movies were the experimental. People who did not watch movies were the control condition. And sometimes in drug studies, for example, if we were doing the coronavirus drug study, we would have a group who gets the drug and a group who gets a placebo. And so sometimes we have a placebo condition as well. So those are a couple of different levels of the independent variable. And each one of those is called a condition. So let's take, for example, in a study considering whether reduced sunlight causes depression, the levels of the independent variable may be 0 sunlight, 2 hours of sunlight, 3 hours of sunlight, et cetera, et cetera. I hope you guys are getting some sunlight out, getting out of your house a little bit. That's something we still can do. We can still get nature, we can still get light, still enjoy spring, even though we can't hang out with each other. Okay, so we can measure the dependent variable in a lot of different ways. So notice that in the last experiment we were talking about levels of sunlight or the independent variable, and depression is the dependent variable. We can measure it in a whole bunch of ways. We can measure self-report. We can ask somebody if they're depressed or how depressed they are. We can measure it behaviorally by how much they sleep, how much they eat, stuff like that. We can also measure it physiologically, although depression may be difficult to measure this way, but sometimes we can measure a level of cortisol or other kinds of physiological measures, heart rate and stuff like that. So you might try yourself to give some examples of each type of measure in the movies in the marriage study. So the dependent variable there would be the quality of the marriage. So what would be some different ways of looking at quality of marriage using self-report, behavioral, or physiological? It's always a good idea to have multiple dependent variables, and we've talked about multiple operational definitions before. So in the marriage quality study where we're looking at whether movies improve marriage, marriage could be time spent together, eye contact, conversation length, self-reported marital satisfaction, all kinds of things there. Yeah, whether people can hang out together a lot in quarantine, because that'll tell you the quality, right? Okay, anyway. So you try, design an experiment to test the effects of exposure to nature for depression. So there's a lot of evidence that exposure to nature is actually good for depression. Question number one, what is the independent variable? What is the dependent variable? What are the levels of the independent variable? Is there a control condition? Is there a placebo condition here? Did you use random assignment, and why did you use random assignment? And what types of dependent variables are you measuring there? Or do you have multiple measures of your dependent variable? So you go ahead and stop the video and test your knowledge there and see how you're doing. Okay, we're gonna stop with this video at this point, and we will go on to, how do I stop the video? Stop. Stop share. Okay. Stop video. Stop share.